we are really excited to present our project, the Interactive Satellite Dashboard, developed for the NASA Space Challenge. The main goal of this project is to create a web-based interactive dashboard that show the real-time position of satellite and space, whether events like solar flames or geomagnetic storms. What make it interesting is that users can also simulate protective actions like moving satellites to safer orbit or activating a virtual shield to prevent possible damage. In short, it's like a mini mission control center where users can monitorize, analyze, and respond to space events in real time. Further, topic will be shared by as a prototype and screen by Sipravil.
Prototype and screen. Let us look at the prototype, what it offers. On the home screen, user can view Earth in 2D or 3D with all active satellites shown as icon. If you hover over an satellite, it shows key information, its name, orbit, and last contact. The color-coded zone indicates safety level. Green means safe, red means high risk. Then we have the satellite detail screen, where you can click on any satellite to open a detail panel. It displays its orbit path, even predicts collision risk. You can also perform simulations like dragging the satellite to safer orbit or activating a shield animation for protection. The alert and simulation screen shows a timeline of upcoming space weather events, helping users schedule action like orbit changes in advance. Finally, the dashboard and analytics screen gives summary, graphs, satellite status, recent alert, and what actions were taken. It even allows users to export report for mission logs. Further tech stack will be explained by Aditya.
Thank you. Now let us talk about the technical part of our project. For the front end, we use React.js or Flutter Web, and for 3D visualization, tools like 3JS and Plotly. The data comes from NASA's Space Weather Prediction Center for solar flares and storms, and Celestec TLE data for satellite positions. So everything is based on real data sets. In coding features, we have included real-time fetching of satellite and space weather data, interactive drag and drop simulations, alert and notifications, and basic predictive logic for collision risks. The reason these projects work so well for the NASA challenge is that it's practical, interactive, and realistic. It uses real NASA data, looks like a mission control system, and has a compact, achievable code base, making it perfect for a hackathon. In short, our dashboard helps users make smarter, data driven decisions about satellite safety. Now, actual prototype will be explained by Ayush and Dhanashri.
Okay, so now I will be explaining the prototype. So the our prototype name is Celestia Sentinel. So this is the Earth view. It is a 2D and 3D. As my teammate said, we will be giving a 2D and 3D model both. And in this, we can show the country names, and even we can hide it by clicking these buttons over here. So we have safety warnings, critical warnings, and events to be upcoming events. And even we provide voice
Voice
assistance.
assistant activated. Celestia Sentinel is now monitoring for space weather events.
Okay, now if I have to see the satellite status, I'll just give him the command show satellite status.
Command received. Report space weather.
Okay, the command will be received, and you will be able to see the space weather. And if I want to give the command for report space weather, so now report space weather.
Command received. Report space weather.
Okay, so that weather report also will be given to us. And now further, Dhanush will be explaining.
बोल बोल बोल.
Here's a timeline. Every significant detection is logged here in real time. Events are clustered by severity and asset impact. Clicking an event expands it to show the detection trace, satellite telemetry, spikes, solar imagery, snapshot, model confidence, and a short natural language summary generated by our AI. From this view, an operator can deploy a mitigation with one click. For example, enter safe mode for SAT42 and the system will push the command through the flight, oops channel and the log action. Here comes our AI Insights section. AI Insights boils down raw telemetry into prioritized intelligence. Fast, instead of shifting to logs, the AI tells you what's most urgent, why will we believe it, and what to do. Every insight includes an explainability, trace, and confidence, crucial for missions. Controls Controllers who need to trust automation. We show model consequences, counterfactuals, and the most sensitive telemetry channels. Now, finally, I conclude here my AI section. Now, we will move to analytics section. Here in analytics section, we will see the satellite status distribution where the it will show the warnings, critical and the possible safety things. Risk level distribution shows a diagram of the risk we can take in our satellites. Space the event shows the current event of this space that tells us what's what's actually the best weather for launching a satellite or what problems can our satellite fill over there. Mitigation action status also indicates the schedule and what we can do over there. Here I conclude my part and hand over to Kavitej.
Moving further, I'm very behalf of my team. I'm very happy to say that we have completed our 100% of front end. We have completed 70% of our back end. Still, we are working on our back end. This was our brief overview of the interactive satellite dashboard. We hope you liked our concept, and we are happy to show a short demo of how is it work in action. Thank you. Thank you so much.